Hello class, this is Mr. Kleinhans for Oceanography Summer School, and today is July 9th. You should have completed all the assignments for July 6th, which was the student contract, Google form. The do now, what do you think we'll learn about in this class? The homework Finding the Titanic. July 7th, there was a do now about the Atlantic Ocean. Aquatic biomes, that's an assessment, which is just like a quiz, and the exit ticket question, which counts as your participation for the school day. July 8th, you should have done the do now about the type of material in the garbage patch and the ed puzzle about marine biomes. Today we'll be learning about decompression sickness, about scuba diving, the properties of seawater, and also an exit ticket for your participation. This deals with temperature and pressure, the do now. What are the dangers and symptoms of decompression illness? Short 2-minute video, which I'll play right now.
Decompression illness, DCI, encompasses two diseases, decompression sickness, DCS, and arterial gas embolism, AGE. DCS is thought to result from bubbles growing in tissue and causing local damage. DCS most commonly refers to a specific type of scuba diving hazard, but may be experienced in other depressurization events, such as flying in an unpressurized aircraft and extravehicular activity from spacecraft. Bubbles forming in or near joints are the presumed cause of the joint pain of a classical bend. When high levels of bubbles occur, complex reactions can take place in the body, usually in the spinal cord or brain. Signs of DCS include skin shows a blotchy rash, muscle weakness, joint pain, collapse, and fatigue. Treatment is by hyperbaric oxygen therapy in a recompression chamber, which slowly recompressurizes the body so that the bubbles may be removed. If treatment early, there is a significant higher chance of successful recovery. Deep, long dives, exercise at depth, or after dive will decrease the chances of DCS occurring. Exposure to altitude or flying too soon after dive also increases the risk of decompression sickness. AGE results from bubbles entering the lung circulation, traveling through the arteries and causing tissue damage at a distance by blocking blood flow at the small vessel level. This usually happens when a diver surfaces without exhaling. Air trapped in lungs expands with ascent and may rupture lung tissue, called pulmonary barotrauma, which releases gas bubbles into the arterial circulation. This distributes them to the body tissues in proportion to the blood flow. Since the brain receives the highest proportion of blood flow, it is the main target organ, where bubbles may interrupt circulation if they become lodged in small arteries. To prevent AGE and DCS, make sure to exhale when surfacing and always service at slow, constant rate.
So that went over the symptoms of the decompression illness, which will help you answer the question there. The main idea is that if you are coming up too fast from a greater depth and you're not breathing out, you can actually get air bubbles inside of your blood, which can cause damage to the tissues, swelling of the joints, and even fatigue and passing out. And it's treated in a hyperbolic chamber, which is just a chamber where they increase the pressure to try and have the bubbles almost like get squeezed out and pop. And it's common, but it's usually not life-threatening. The next topic we'll be covering is temperature and pressure and the properties of the seawater, properties of the ocean. So with temperature and the ocean life, many marine organisms are called ectothermic, meaning they're cold-blooded, and their temperature depends on the temperature of their environment. So an increase in temperature will increase the body temperature, and then they'll have to actually increase their metabolic activity. What happens if the temperature rises too high? Well, if the temperature gets too high, they can actually cause damage and death. If the temperature drops too low, they can destroy the enzymes involved in cellular respiration, and they get no energy, which results in damage or death as well. Pressure underwater. As you go deeper in the water, the pressure increases. The water in your town of Freeport, in our town here, the water has coming from the water towers. Water is pumped up into the top of the tower and then it gets pushed down due to pressure. So we get pressure coming out of the faucet. Humans are not ectothermic, we're called endothermic, which means that we need to generate our own heat. So our body heat is lost 25 times faster in the water than in the air of the same temperature. Very cold water can cause hypothermia, which is excessive cold. The results drop in a low body temperature. You can actually lose consciousness and even die. The deeper you go, the more pressure there is. That's the main topic here. They call it hydrostatic pressure. Hydro means water, hydrostatic pressure. For every 10 meters of depth, the water pressure increases by 1 atmosphere, meaning 1 time greater than what you feel just with the air pressure around you. So pressure and ocean life. Diving mammals like dolphins have flexible rib cages that can expand and contract depending on the depth. Deep sea fishes cannot survive at a shallow depth. They're actually swim bladder, like they have air inside of them, actually causes them their stomach to almost like expel out of their mouth. People and pressure. Special activities has scuba equipment allowed man to do underwater. Well, they can go and look for anything they want underwater now. There are injuries called barotraumas. You have injuries going down. You feel the pressure even like when you're going swimming. You feel the pressure on your eyes and ears and nose. And then rising up too fast can give you a problem called the bends or a decompression sickness, which gives you those air bubbles that we talked about for the do now. So if you rise too quickly, air bubbles form in the blood as your ambient pressure decreases, and this can cause pain, even death, but very rare for death. Why is this decompression illness called the bends? Well, it caused the diver bends over in pain. So they called the bends a long time ago because when a diver would come up, they'd have it, and then for a day or two they'd be bending over in pain because all these bubbles in their joints were causing so much pain in their back and their neck and their joints. If you have an air embolism, that could even cause you to for even death. So they ask you to breathe out while you're ascending and descending, meaning breathe normally. Nitrogen narcosis is another type of injury. On special dives below 30 meters, that's like almost 100 feet, a diver can experience rupture of the deep or nitrogen narcosis when breathing nitrogen under pressure. This can be coming from the actual scuba tanks. It acts like a narcotic, like a drug, like nitrous oxide, and you actually can feel like you're almost intoxicated at the bottom of the water, and that's not good because you can get disorientated. You can actually people get so uneasy and unaware of the surroundings, they pull their mask off and they can actually breathe in water, and then they die from that. So that's another injury. They put helium in the tanks now to prevent that. Osmotic pressure and aquatic adaptation. So osmoregulation. It's the ability of an aquatic organism to maintain the correct water balance within their bodies. So they can actually determine the movement of water from an area of high concentration to an area of low concentration through a semi-permeable membrane. A sea star. What happens to a sea star when it's placed in fresh water? Well, the water molecules will move far from where they are, more concentrated outside of the sea star to where they are less concentrated inside the sea star. But this can actually cause the pressure to be happening regulated too fast, and it can cause death of that sea star. A goldfish. Put a goldfish in the salt water. Well, the salt water is going to try and get in, and all the fresh water is going to get out, and the goldfish will actually die of dehydration. The best osmoregulator is a salmon because it actually can go out in the ocean and spend time out in the ocean, which is salt water, and then can swim back up the rivers and live in the freshwater rivers as well. So the water molecules will enter the fish by inward osmosis, and the salmon will excrete a diluted urine. That diluted urine is going to be the salt water coming back out. So at this point, you should have been able to. At this point, you should be able to complete the do now, dangers of decompression sickness, and the assessment for today is properties of seawater, saltwater, seawater chemistry. So click on the Google form, brings you to the reading that you have here about seawater chemistry. What do you get when you evaporate seawater? You get salt. Human bodies need salt to live. Nowadays, most of the salt comes from the oceans or saline lakes, which is salt lakes. Some salt comes from rocks that are evaporated from the seawater. The makeup of the ocean water. You know that ocean water is salty, but how salty is it? What is the salinity of seawater? The average seawater is about 3.5% salt. The amount is different if there is a nearby source of fresh water. It's also different if there's a lot of evaporation in the area. How do you think these things affect seawater salinity? Seawater also contains other substances like sugar, acid, bases, and organic molecules. So the main thing is, why is the ocean water salty? Well, dissolved minerals came from the rocks, and these ions, which is just dissolved salt, enters the water. This happens when the water flows over through the rocks, and that water, gets from runoff into the oceans. How salty is it? Well, it depends on where you are. It's about 3.5% of the ocean water, which is why we cannot drink ocean water. It will make you sick and even cause you dehydration. The main components are sodium and chloride. Together they form salt known as sodium chloride. You may know the compound as table salt or the mineral halite. The amount of salt varies from where you are. If you're near an ocean, it's going to be more salty. If you're near a river, it's going to be less salty. And the temperature also determines the salinity. The higher the temperature, the more salt that can be dissolved in that water. The main thing is water density increases as salinity increases. The temperature will decrease and the pressure will increase. Differences in water density are responsible for deep ocean currents, as will be discussed in the concept deep ocean currents, which will be on the next week. So your summary is water moving through rocks and soils picks up the ions, causing these ions to end up in large bodies of water. Ocean water contains salts and other substances, and this is very important here. Water density increases as salinity and pressure increases, or as temperature decreases. So the main thing is, the more salt it is in there, the more dense it is, right? But the colder the temperature, the more dense it is as well. So like cold water will sink down much quickly, and then if you have a lot of salinity, it's going to be more dense as well. So this video here will actually review all the topics that I just went over, and also you have that information up here to read in order to answer these questions, and that will count as your assessment for this week. So if you have any other questions, you can post them now as comments. You can ask them on the Google Meet through the chat. It's up to you. The final assignment for today is going to be the exit ticket. The exit ticket is about pollution in the ocean, dealing with the Hudson River. So this is another one we just read through here. The questions are going to be here. Number one, why was commercial fishing for striped bass banned or stopped in the Hudson River? Explain why it is now safe for people to swim in the Hudson River again. And why is a cleaner Hudson River important for the survival of the striped bass type of fish? And all that will be answered right here in this reading about pollution in the ocean. The Hudson River, goes through New York State, starting in Hudson Bay, where the Statue of Liberty is, and goes up the river straight to the north, very long river. And what happens is there was a lot of industry, and they would dump a lot of their pollutants into the river, causing a lot of pollution that actually killed off and made a lot of the striped bass too toxic to eat, and made the water too pollutant for them to actually survive as tiny, small fish. Then they started cleaning it up through a lot of Clean Water Acts and different legislation, and now it's much cleaner. So if you read through that, you'll be able to answer those questions. So good luck, and I'll talk to you guys on the chats.